Okay, we'll do.
Every work of art is about how entertaining it is.
Okay. So we've got the equipment working. Say hello to Lexi and Ethan again.
Hi, Lexi and Ethan.
You can. Go ahead.
We'll probably be joining you in the sick ward soon.
Wait, no, don't do your face.
Okay, just take it. No, because then it's going to get me.
No.
That was Brittany's hand. Okay. So today we're doing lesson 5.6, inverse trig functions and derivatives. Thursday we're going to do integrals. Next Tuesday is review. Next Thursday is the test. Yes. I know, but we only had 3 more lessons in chapter 5. After Thursday, we're done with chapter 5. And then we'll have a test over all of chapter 5.
Yikes.
Okay?
Oh, Jesus, it's gonna be hard.
So we're going to get through it.
Really?
But to start this, let's review pre-cal inverse trig. Okay? So inverse trig functions. Let's remember that I could have y equals inverse sine of x, and that does not equal 1 over sine x, right? That's inverse sine. The other way that we could write this is y equals arc sine x.
Oh, right.
So it does refer both ways in our book, okay? So if you remember, there were specific ranges that inverse trig functions were valid on. Well, that's where the functions were positive. All students take calculus.
Like, this was on quadrant 1 and 4.
Yes. Okay, so if I have my function y equals arc sine x, the domain and the range, and again, we restricted the domain of the regular y equals sine x, the parent function, so that it would pass the horizontal line test, so it would have an inverse. Because sine does not pass horizontal line test as it is, as it goes to infinity. But if I restrict it so that it will pass the horizontal line test, then I do have inverse trig. So y equals arc sine x, the domain is negative 1 to 1. Okay, and domain and range are flipped from the original function. So that was the range of sine x. Now this is the domain of arc sine x. And the range, negative pi halves to pi halves. So Andrew had said quadrant 1 and 4, but more specifically, it's negative pi halves to pi halves. Right? I cannot say 3 pi halves.
Didn't we do this by doing little x's?
Yes, and we can do the little x's here in a second.
Okay.
Okay?
I remember the x's.
Yes. Y equals arc cosine x. Domain, what do you think it is?
It's 1 and 2. Oh, domain is negative 1 to 1.
Negative 1 to 1, just like sine.
Range is 0 to pi.
0 to pi. Okay, we can go in and put the x's. Let's do that. So arc sine, 1 and 4, 1 and 2. Okay. And then we have y equals arc tangent x. Its domain, what is the range of domain? What is the range of tangent x? Not inverse tangent, the straight up tangent. What is the range? Think of the graph.
Then the tangent,
Uh-huh.
same sign.
No.
Arc sine.
Nope. The range, so tangent x, over here I'm going to draw a little picture. Tangent x looks like this,
Oh, yeah.
with asymptotes. Right? So the range, if this is tangent x, the range,
It's going to be on every...
it's all real numbers, negative infinity to positive infinity. That is the domain
How is it the domain?
of inverse. Because domain and range switch. The domain of the function is the range of the inverse. The range of the function is the domain of the inverse.
That makes sense.
Okay?
I never
And then
understood that much.
its, does anybody know what quadrants? What is its range going to be?
It's the same quadrant as sine.
Same as sine, except I can't have negative pi halves and pi halves included.
Oh, because it's on the pi halves.
Because then I have, because at pi halves,
It's the
cosine is 0, that's where the asymptote is, and it's undefined. So here I am here, right? But I'm not including the endpoints. Okay, then let's come down and do y equals, well, let's do arc cotangent. Domain, all real numbers, just like tangent. Okay, and its range is 0 to pi
Not
with
included.
parentheses, not included.
And it's
Okay, y equals arcsecant. Oops, sorry. Let's not put that. So y equals arcsecant, and this is where I'm going to have absolute value of x is greater than or equal to 1. Okay, but if we think about that, that means that x is, I could rewrite it as x is greater than or equal to 1, or x is less than or equal to -1. And we can think of the u's, right? The secant graph is the u above the crest and trough of the cosine curve. Okay.
That says x is,
X is greater than or equal to 1, or x is less than or equal to -1. So remember, I'm going to draw up here. So here is cosine. Okay? That is not secant. Secant is the u's. Okay? So secant's range is y is greater than 1 or less than -1. So that is going to be the domain of the inverse. Okay?
Based on the amplitude.
Based on the amplitude, but we're talking parent function, so it's going to be 1.
Yeah.
Okay, its range is going to be bracket 0 to pi, but y cannot equal pi halves. So I am like this, and I'm going to put a little x on the axis because I cannot include that. Okay, y equals arc cosecant x. The domain is going to be the same. Absolute value of x is greater than or equal to 1, or x is greater than or equal to 1, or x is less than or equal to -1. And the range, any idea? Where's the range going to be?
Wait, so that's the same thing as, the range is the same as secant and cosecant?
No, it's not the same as secant.
Well, no,
Sec-
not the domain.
The domain is the same.
That's what I mean.
Yes, the domain is the same.
The range for cosecant is going to be,
The same as sine,
oh, that makes sense.
right? The secant, inverse secant, is going to be the same as inverse cosine, except where cosine equals 0, which is halfway through that. And so this is going to be negative pi halves to pi halves, but y cannot equal 0, because that's where sine equals 0, and then you have 1 over 0. So here I am like this, and I'll put a little x on that axis to say it's not included. Okay. Let's do a little pre-cal. Just straight up inverse trig. Okay, and this is why I thought it would be helpful if you guys, Lexi and Ethan, if you have your best friend from pre-cal, take it out, because it may be helpful to look at the unit circle while we're doing this. Okay, so now not that you don't have it memorized, but it's just easier just to have it in front of you. Okay, can I go on to the next page? Okay. So this is example number 6. And it asks you to evaluate arc sine of 0. And this is where last year I told you if you're asked to evaluate this without a calculator, because you could just plug this in your calculator, but if I asked you to evaluate this without a calculator, set it equal to theta. Okay? And if I were to do the inverse sine of both sides, it would cancel out this, and basically what I did last year is I put in quotes, where does sine equal 0?
No, because then it becomes theta equals
So,
sine inverse 0.
yes, yes. Theta equals inverse sine, that's what we just said, or sine theta equals 0, right? I can think of it that way. Sine theta equals 0. But I know inverse sine, because there's two places on the unit circle that sine equals 0. But only one of them is valid because of the restriction on the range of inverse sine. Andrew, what is it?
0.
Theta equals 0. Okay. Okay, that is where sine equals 0. At 0 degrees or 0 radians, sine equals 0.
But we can't say pi
Because that's not in, if I come back here, we can't say pi because pi does not lie between negative pi halves to pi halves. Does that make sense? Okay. Let's do another one. Example number 10. Same exact instructions. It gives us arc cotangent of negative square root 3. So this is asking where does cotangent equal square root 3? So I can say cotangent theta equals square root 3. Cotangent,
Negative square root 3.
negative square root 3, sorry. Yes, thank you.
Cotangent is sine, cosine over sine.
Yes, cotangent is cosine over sine,
So that means it would have to be
x over
square
y.
root 3 over 2 all over 1 over 2.
Yes, so it needs to be square root 3 over 2 all over 1 over 2.
1 has to
And it has to be negative. So either x has to be negative or y has to be negative.
be. Cotangent is only valid in 1 and 2.
Cotangent is valid in 1 and 2.
So it
Quadrants
has
1 and
to
2,
be
0 to pi.
quadrant 2.
Has to be in quadrant 2.
Mhm.
Exactly, because everything is positive in quadrant 1.
So it's pi, it's 5 pi 6.
Yes. So theta equals 5 pi over 6. That is where cosine equals square root 3 over 2 and y equals 1/2. Well, cosine equals negative square root 3 over 2. Y equals 1/2. 2 pi thirds. I should have my best friend out while I'm doing this.
2 pi thirds? Is it because the cosine?
Because it would be 1 over square root 3. Does that make sense? Okay. That's tangent, not cotangent. That's okay.
Is
gonna
that
t-
negative square root of 2?
Negative square root 3 over 2.
Sounds like someone else needs some glasses.
No, I think it's not focused exactly the way it should be. Which,
It
looks bad.
confusing, too.
do I even have a best friend? That's sad for anybody listening to this. Do I have a best friend? Yes, I do. Okay. All right. Let's do, so this is our final answer here. Let's do example number 18. I'm going to write a little bit bigger so it's a bit easier to see. So example number 18 has two parts. A is tangent of arc cosine of square root 2 over 2 and parenthesis. Okay, just like with PEMDAS, what PEMDAS says we do what first? We work with inside the parentheses. Arc cosine of square root 2 over 2, where does cosine equal square root 2 over 2? Pi fourths. Okay? Cosine also equals square root 2 over 2 in quadrant 4, but that's outside of the range. It has to be 0 to pi, quadrant 1 and 2. So this is equal to pi fourths, and I can take the tangent of pi fourths, it equals 1.
This makes so much more sense than it actually.
Okay?
I
It's
like-
because it's the second time you've seen it.
Yeah, I know, but that's very intense on the whole year. Like you just be like, okay, oh,
Oh, yeah. All right. It seems to be making sense to everybody. Let me throw this one at you.
What is that?
Cosine of arc sine of 5 over 13.
What?
Well, it's gotta be something with the triangle.
The triangle. Okay? So,
It's positive.
sine, it's positive.
Quadrant 1.
So it's quadrant 1 because sine is valid quadrant 4 and quadrant 1. So I'm going to come here. Sine is opposite over hypotenuse. So this is 5, 13.
12. So cosine is 12.
Okay, so the last side is 12 because it's Pythagorean triple. Okay, now this triangle is representing everything inside the parenthesis. This is theta.
So we say cosine of the triangle is what?
Yes, cosine of the triangle is what? Right?
12.
No,
Yes, it is.
cosine is 12 over 13.
Oh.
Right? So cosine is adjacent over hypotenuse, so I have 12 over 13. Okay? Does that make sense? Okay. That's okay.
Did I tell you that whenever Mrs. Krasinski taught, she used triangles for everything?
Yes.
They didn't memorize the circle.
I know.
That sounds awful.
Yes.
Like, how long would it take to do a problem?
Well, you just sketch out the triangle every single time. Yeah. Yeah.
Whenever I was like,
There's
okay,
other
so-
schools that do that. Are you ready, Scott? Okay.
You just said you said-
Let's
I
do
didn't realize that.
example number 28. Okay, same kind of concept of where we have to draw the triangle and take the trig of the triangle. We have secant of arctangent of 4x. Okay, I need to draw a triangle. This is variables. We don't like that as much. First of all, No. First of all, which quadrant, I can assume that this is positive.
Says
If
10.
I have variables, I can assume it's positive and it's going to be in quadrant 1.
Okay.
Okay? So if there are variables and I'm drawing a triangle, put it in quadrant 1. And so I'm going to put this here. This is 4x, and I can imagine it's over 1. Right? 4x is the same as 4x over 1. And tangent is opposite over adjacent. So this is 4x, this is 1. What is my hypotenuse?
You have to,
The square root of 1 plus 6.
it's 16 x.
Yes, so I need to use Pythagorean theorem and say, so a squared plus b squared equals c squared. Well, here I have 1 squared plus 4x squared equals c
So
squared.
it's honestly just going to be 4x, right?
No.
Because then you have to square root it to get c.
Yes, so c equals square root 1 plus 16x squared.
Oh, I forgot about the 1.
Okay, yeah. Can't forget about the 1. So this is 1 plus 16x squared. Can you see it? 1 plus square root 1 plus 16x squared. All right, guys, I'm going to stop the video. I'm going to try and focus it, and then we'll come back.
Okay.
Lexi and Ethan, hang tight. See us in video number 2.